Let's have a look at an example to make this concept of the normal distribution and its implications more clear to you. So every day I have some cereals and I use a lot of Laban. So therefore I choose Laban as an example. Let's assume we are a grocery store like Lulu, Nesto, Carrefour, whatever, and we know that in our store on average we sell 200 bottles of 2-liter Laban every day, though the average daily demand is 200 units. We calculate or we look at the numbers and for 1 month, for example, and we realize that the standard deviation is 40 units. This is all done by basic statistics. So now the manager of the store wants to know how many of these 2-liter Laban bottles need to be on inventory to satisfy the customer demand with a probability of 50%, 85%, 98%, 99.9%. So to average half of the customer demand, or to satisfy the customer demand with a 50% probability, we take the same number as the average daily demand, 200s. To satisfy the customer demand in 85%, we take the average plus 1 standard deviation. So 200 plus 40 equals 240 units. For 98%, we go for average plus 2 standard deviations, so 200 plus 2 times 40, and 99% service level is achieved if we go for 3 standard deviations, 200 plus 3 times 40 units. So now if we have 320 units of Laban in inventory, we almost always satisfy our customer demands. That's pretty good. Of course, we need much more storage space to do this. So now we need to calculate a trade-off between the additional storage space and the increased customer demand. And you can also see how the cost for having a higher customer service are increasing exponentially. It's very easy to increase the customer satisfaction from 50% to 85% by adding 40 more bottles. But then going from 85 to 98, we need again 40 bottles more, and going from 98 to 99.9, we need again 40 bottles more. Though you see this relationship between the service level and the cost, how it increases exponentially. This is what you can do with the normal distribution and the knowledge how the costs and the demand develop under the normal distribution assumption.